Hey guys, in this video we're going to cover movement. It's actually pretty easy, so let's get started. So I'm right where we left off in the menu scene, and the first thing we should do is head up into the Bolt Asset menu, and you get to that by going to Window, Bolt, Assets, and then making sure our custom cube state has the transform property on it. If you don't have that, just go to New Property, name it Cube Transform as we have it right there, and then set this to transform. We already have that done, so I'm just going to press Control and then remove it as so. Something else that will come in handy is also setting the smoothing algorithm to interpolation. And then once we've finished with that, go ahead and compile everything and wait until you get success debug statement loading. It should have appeared. That's just because I have debug off, but there is our success. So the compile worked. All right, now that we know the transform is attached to the cube, let's head into our prefabs, go to our cube, and then let's add the script that will control movement. So let us just call it player movement. Go ahead, new script, player movement looks good, and then hit create and add. Once that finishes loading, you should see here it created a new script, and then you can open that up in Visual Studio. Once again, let's go ahead and clean up this script. We won't need anything that is already written, so just go ahead, remove everything, and then this will actually be a pretty easy script. But again, with Bolt, instead of deriving from mono behavior, we actually want to derive from bolt.entity behavior. And then the entity we want to derive from is the cube state. So you can type in cube state or whatever you named it. And then it'll put I in front of it. So I and then whatever you named it. And now we can access all of the properties we added to it from the assets menu. So right here, right now we can only access the transform property because that's all we have. But if you add more, for instance, if you added any of these things, deriving from it with the bolt.entity behavior, you can access that in script. So the first thing we want to do is synchronize the local transform data with the bolt transform data. And to do that, we use another pre-made function with Bolt, and to use any pre-made Bolt function, we do public override void. And now we have access to all of theirs. We want to use attached, and this is actually the same thing as void start, but it's called when the entity loads into the game. So with that being said, now we go ahead and do state.set transforms, and then we want to set the state.transform.cube transform, because that's what we named it. And we want to set that to our current game object.transform. And we don't actually have to say this, it'll just interpret that. So if you want to keep the game object, you can, but it'll work just fine like that as well. And for the movement itself, we're going to want to put the detection. So if any key input, we want to put that in an update function as we would normally. But again, with Bolt, just like the attached function, they have their own function for update. So we're going to call the Bolt version of update with public override void. And then we're going to use simulate owner. This is the same thing as the update function, as I was saying, but it is only called on the owner's computer. And then inside the simulate owner, it's actually going to be pretty standard stuff. I won't go over it too in depth, so let's just go ahead and make a var called speed and set that equal to 4-ish. You can probably change that from the inspector, it'd be a better way to do it, but for now 4 is probably fine. And then we'll make another one and we'll name it movement and set that equal to vector 3.0, which just means for every vector for x, y, and z, it will be 0. And then we can say if input.getKey key code dot, well, let's start with A. So if the user presses A, we are going to change movement dot X, and we're going to change it by minus equals 1, so it makes sense in a second. Let's just copy and paste this. So this is for moving left. We want the x-axis to be -1. Keycode dot D, this is going to be for moving right, so we want the x-axis to be positive to indicate direction to the right. And then we can copy and paste both of these for the up and down movement. So for the up movement, we want keycode dot W, and we're actually going to want the z-axis this time. And I said it was going to be W, so we want it to be positive. And then lastly, for S, we want it again on the z-axis, and we want it to indicate movement down. And finally, we can finish that off with if movement does not equal vector3, goodness gracious, vector3.0, meaning again, any of the x, y, and z, if it's not 0, which we're changing here, if any of the input changes it away from 0, we want to transform dot position equal to transform dot position. So the same position plus movement dot normalized times speed, and then we want to multiply it by bolt network dot frame delta time. If you've ever used time dot delta time, it's the same thing except over the network's delta time. And there our movement should be working. And something stupid that I just realized is we actually are not deriving from I cube state. We are deriving from I custom cube state. The regular cube state is from their tutorial pack, and it has a transform already, so it would have been easy to be confused. But anyway, so derive from custom cube state, or whatever you called it, and with this done, we actually should be good to go. So let's go ahead and save everything like so. Head back into Unity, and yeah, we're good to go. So go ahead and build and run. Once that finishes building, go ahead and click Window again, and then play. Drag that off to the side and start your editor. Just to prove that it will work this time, I'll host the game from the build, and then wait for our little cube to pop up. We can't see him, there he is. And then movement, bam, should be working. All right, so let's leave him right there. Head over to the editor, and then since we're hosting on this, we'll go ahead and join here. Looks like it's working, and we want to allow that. And moment of truth, it works. Hey guys, thanks for watching. I hope it helped. You'd really do me a huge favor by sharing these videos and just telling people about it. And other than that, yeah, I'll see you next time.